right, so we are going to pick up with our math concepts and look at significant figures. This looks at kind of how exact a measurement is. So if we're using like a ruler or graduated cylinder, looking at where we should include an estimated digit. Whenever we're doing math, this also is going to give us a clue of where we should round to. So with significant figures, these are the digits of a measurement, including all known digits and an estimated digit at the end. So this a lot of times we will use when we're measuring. So say that we have a ruler and here is 51 and here is 52. Say that our mark is right here. Well, we know it's at least 51 centimeters, but it's more than 51. So we would need to add an estimated digit on there. So we could say that this is about 51.3 centimeters. Now you're kind of eyeballing it because you don't have tenths places there. You're just looking at how far between 51 and 52 is it. So you might have it down as 51.2, 51.4, something like that. But you're always going to add one extra digit smaller than your smallest graduation or your smallest marking on that tool. So if this had tenths marks on it, we would need to add a hundredths place. That's that estimated digit on there. We are going to be responsible for counting significant figures and writing numbers with the correct significant figures. So whenever you're given a number, being able to figure out how many significant figures, or when you're doing a calculation where you should round to. So let's explore that a little bit more. So with significant figure rules, we can count how many significant figures or how many digits are in a number based on the Atlantic Pacific rules. And I apologize for my drawing skills, but I draw like kindergartner. So here's my map of the US. We have the Atlantic Ocean is on the right, the Pacific Ocean is on the left. So the Atlantic Pacific rules kind of give you an idea of what side of the number you should start counting from. So if the number does not have a printed decimal point, the decimal is absent. We're going to start counting on the Atlantic side of the number. So start from the right of the number, and we're going to read this number from right to left. And we're going to start counting digits once we reach a non-zero number. And then once you start counting, you count every digit after you have started counting. So for example, here we have the number 400, 400. This does not have a printed decimal point in it. So we start from the right side and we go from right to left. Our first non-zero digit from the right is the 4. So this number only has one significant figure. Anytime you see SF, that's significant figure. Another way you might see this is if we have like 1070 as a number. There's no printed decimal point, so we would start from the right and read it from right to left. Our first non-zero digit from the right is 7. And once we start counting, we continue counting. Yet again, we're reading from right to left. So this number has 3 significant figures. Then there's what if there is a decimal point? So if the number has a decimal point, we say that the decimal point is present. We start on the Pacific side of the number. So we start at the left of the number and we read the number from left to right. And yet again, we start counting once we reach a non-zero digit. and we count every digit until the end of the number once we've started counting. So here I also have the number 400, but it is 400.00. This has a printed decimal point. So we start on the Pacific side, we read from left to right. Our first non-zero digit from the left is 4. And reading from left to right, we have to count every digit once we've started. So this number has 5 significant figures. This is also going to come into play if we have a decimal number. So say that it's 0.030. This has a printed decimal point, so we would start on the left and read from left to right. Our first non-zero digit is 3. And once we start counting, we continue counting every digit after that. So this number has 2 significant figures. And this will take a little bit of practice getting used to how you're determining which zeros count and which zeros do not count. All right, so let's look at a couple of these. It wants to know how many significant figures are in the following measurements. So yet again, you have to pay attention to, is there a printed decimal point or is the decimal point absent? So this first number, 0.05730, there is a printed decimal point. So remember, we are reading it from left to right. We're starting on that Pacific side. Our first non-zero digit from the left is 5. And reading from left to right, we count every digit after we've started. So this has 4 significant figures. Looking at the next one, we have 8,065 meters. This does not have a printed decimal point, so we are reading it from right to left. Our first non-zero digit from the right is 5, and we count every digit after we started. So this also has 4 significant figures. Let's look at the next one, the 0.00073 grams. This has a printed decimal point. So we start on the Pacific side, we're reading from left to right. Our first non-zero digit is 7. And once we count the 7, we continue counting from left to right. So this has 2 significant figures. I'm going to skip the next one. I'm going to go to the 1,430 grams. The decimal point is absent. So we're going to start on the Atlantic side. So we are reading from right to left. Our first non-zero digit from the right is 3. And then reading from right to left, we count every digit once we've started counting. So this number has 3 significant figures. The last example I wanted to bring up, because we do deal with numbers in scientific notation quite often, and pardon me, that should be to the -2. My superscript disappeared. Whenever you have a number like this, you're only going to pay attention to that coefficient. You're kind of ignoring the times 10. So here, there is a printed decimal point. So we start on the Pacific side. So we're reading from left to right. Our first non-zero digit is the 8. And once we start counting, we count every digit after that. So this number has 4 significant figures. So practice that, and really it's going to be those zeros either at the front or end of a number that we're going to be questioning whether they count. All right, so let's look at what we do when we're doing math and trying to figure out where we round to. There are 2 different rules regarding rounding with scientific notation or significant figures, excuse me. There's one rule for if we are multiplying and dividing. Then there's another rule if we are adding and subtracting. So let's look at the multiplication division rule. In general, the calculated number cannot be more significant than the number of digits in the measurements used in the calculation. In other words, your answer cannot have more digits than your original numbers that you used to get that answer. So for example, if we need to find the area of a floor with a length of 7.7 meters and a width of 5.4 meters, When you do 7.7 times 5.4, your calculator gives you an answer of 41.58 meters squared. Notice that our two original numbers, the 7.7 and the 5.4, both have two significant figures. 41.58 has 4 significant figures. Our answer cannot have more digits than our original numbers. So since both original numbers only have 2 significant figures, our answer cannot have more than 2 significant figures. So when we round it to 2 places, we're rounding to the ones place. So that would round up to 42 meters squared. So whichever one of your original numbers has the least number of significant figures, that's how many significant figures your answer should have. So if the two measurements have 2 different numbers of significant figures, it should have the least number. So if one number has 2 significant figures and the other has 3, your answer can only have 2. It's whatever is the least number of digits or the least number of significant figures. So let's look at what happens when we add and subtract, and we're going to do a couple examples with these. So the rule for adding and subtracting is that the calculated number should be rounded to the same number of decimal places as the measurement with the least number of decimal places. So we said a multiplication division, you're rounding to the least number of digits. Addition, subtraction, you're rounding to the least number of decimal places. So let's do some examples and kind of put this to use. And I would suggest putting this in the calculator and figuring out your calculator answer first before trying to figure out where to round to. If you try to do too much at once, you tend to miss things. So let's do a couple from the top section. So it says solve each of the following and give the answer using the correct number of significant figures. So our first problem we have is 61.2 meters plus 9.35 meters plus 8.6 meters. I would punch that in the calculator first and then figure out your rounding. So 61.2 plus 9.35 plus 8.6. Your calculator answer is 79.15 meters. Now we're adding. So remember the rule for addition, subtraction is you round to the least number of decimal places. So 61.2 has 1 decimal point, 9.35 has 2 decimal points, and 8.6 has 1 decimal point. So our least number of decimal points is 1 decimal point, that 10th place. So our answer, we want to round to the 10th place. So that is going to change to 79.2 meters. That would be our correct answer to the correct number of significant figures. Let's skip the next one and do the more word problem one, where it says find the total mass of 3 diamonds that weigh 14.2 grams, 8.73 grams, and 0.912 grams. If you add those 3 in the calculator, it gives you a total mass of 23.842 grams. Now to figure out where to round to, yet again, we added, so we're looking to the least number of decimal points. 14.2 has 1 decimal point, 8.73 has 2, and 0.912 has 3. So our least number of decimal points is 1 decimal point. So we're rounding to that 10th place. So this would be 23.8 grams. That would be our answer in the correct number of sig figs. So now let's look at multiplication division. So solve the following, put in the answer in scientific notation with the correct number of significant figures. Don't forget units. So this kind of puts together sig figs and scientific notation that we looked at yesterday. So, and this tends to be what we come across more in chemistry because we tend to multiply and divide more than anything else. So the first one, we have 8.3 meters times 2.22 meters. When you put that in the calculator, you get 18.426. And that's meters times meters is meters squared. So remember, multiplication division, you are looking at the least number of digits, the least number of significant figures. 8.3 has 2 significant figures. 2.22 has 3 significant figures. 2 sig figs is less than 3, so our answer needs to be rounded to 2 sig figs, which rounds to that ones place. So this would end up being 18 meters squared, would be our correct number in sig figs. To put this in scientific notation, because sometimes, especially on multiple choice problems, the answer might be in scientific notation, even though that's not what your calculator answer is. So remember, scientific notation, there has to be one non-zero digit in front of the decimal point. So the decimal point would go after the 1, so it would be 1.8. Then that would be times 10, and we move the decimal 1 place. So that is a possible answer. So don't be alarmed if you're not seeing what is on your calculator as an answer. Check to see if it is rounded or if it is in scientific notation. That's kind of a common thing that has messed up people in the past. All right, let's look at the next one. We have 8,432 divided by 12.5. Our calculator answer is 674.56. That would end up being meters based off of the units that we have. Looking at, because we're dividing, we're looking for the least number of digits. 8,432 has 4 digits. 12.5 has 3 digits. So our answer, we need to round to 3 digits, which would round to the ones place, which would end up being 675 meters. Looking at this last one, it says calculate the volume of a warehouse that has inside dimensions of 22.4 meters by 11.3 meters by 5.2 meters. So volume is length times width times height. So you multiply the 3 together. And this gives us an answer of 1,316.224, and that's meters cubed. Sig fig wise, 22.4 has 3 digits, 11.3 has 3 digits, 5.2 has 2 digits. So our answer needs to be rounded to 2 digits. This is something that messes people up a lot. So 2 digits rounds to the hundreds place. You still need to show that this is close to 1,300, not 13. So put placeholders in if needed. So that would just stay the same. So it would be 1,300 meters cubed. Scientific notation, I forgot to do on the last one, so we'll go back and do that as well. Scientific notation, we would have 1 non-zero digit in front of the decimal, so it would be 1.3 times 10, and we move the decimal 3 places. And don't forget to include your units on there. Back to the previous one, scientific notation, the non-zero digit would be 6, so it would be 6.75 times 10, and we move the decimal 2 places, so that would be to the second. So just be conscious of figuring out where you need to round to. But like I said, if you need to figure out that calculator answer first and then figure out the rounding, that may help you a little bit more. You can continue working on your Unit 1 math homework. The very next section is all significant figures, so counting significant figures. And then it has some math problems where you're figuring out where to round to.